What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to use our bearings knowledge from last lesson and really use some trigonometry to work out our position in space. Specifically, we're talking about how far north or south we are, or how far east and west, based on a given position. These questions always start with a compass and an origin point, or U in the middle. And what I want you to imagine is you're sitting there and someone gives you a map and says, boom, there's treasure here at this red spot. But they can't tell you exactly where it is. They don't know how far and they don't know what direction. One of the ways to find this without a compass or the exact coordinate is you could go directly east until you got in line with it and then down south. And you could see here that we've got the two short sides of a right angle triangle. When we match that triangle back up, we've got the shortest path, or as the crow flies, to exactly where you are to the treasure. So every time we map our east and west movements with our north and south movements, a right angle triangle is formed because these two directions are exactly perpendicular, meeting at 90 degrees. So that means if we get any of these questions, where are you? Where are these two people in space? All we're really doing is drawing a triangle, and then it's a one-step trig problem that we're already great at. A very classic question would be something like this. Reggie walked 700 meters south and then 200 meters west. Where is he compared to where he started? So what we've got to do is firstly draw this out. We've gone south 700 meters and we've got to draw that in and label it straight away. Then we've gone 200 meters to the west and we're drawing that in too. So what we've got to work out is firstly, how far away are we, the distance, and we also have to work out what compass bearing did we leave on. So you can see from here, it's pretty easy. It's just a right angle triangle. We're going to find the bearing first. So we've got tan of theta is equal to 200 over 700, opposite over adjacent. That means that theta is just tan minus 1, 200 over 700, bang that into your calculator. That answer is 15.9 degrees, but this is not the bearing that we went off. That's just the angle that this triangle makes. So we could say we went south, 15.9 west is one way to write it, or we could say that we've gone at 195.9 degrees because we've done that whole 180 to get to south, and then the extra 16 degrees. So now we've got our bearing, but we've also got to find out our distance, and this is where your boy Pythagoras comes back. So we know with Pythagoras that its distance squared is equal to 700 squared plus 200 squared, and that's equal to 53,000 meters. We've obviously got to square root both sides, and we're left with d is equal to 728 meters. So this means my final answer is the distance that I went with the direction. So my distance is 728 meters, at 195.9 degrees, full marks. This is exactly where he was compared to where he started. So we can also ask you a question where we're trying to find just one direction. So how far north did Sally go? So Sally's run 4.7 kilometers at 330 degrees. And to draw that out, we've got our 330 degree line, which is just 30 away from true north. And we've got to label it 4.7 kilometers. Because we're only interested in how far north she's gone, we still just have a right angled triangle with an unknown side length. From here, it's pretty easy. We've got cos because we have the adjacent and the hypotenuse, and cos 30 is equal to north over 4.7. To get n by itself, we've got to multiply by 4.7. So 4.7 cos 30 is equal to how far north we went. And if we throw that into the calculator, north is 4.07 kilometers, which again makes sense because it had to be less than the hypotenuse. So this is all we need to do for this topic. We have to put down our bearings correctly, make a right angle triangle, and then just use one or two step trig in order to get these completely right. Thanks so much for watching this lesson, and I'll see you later.